In this video, we'll finish the two examples from section 3.2 that we did not finish in class. Okay, so this section, remember, was the definition of the derivative, but what would be established is that we could make a function from it, meaning that I could create some kind of rule, formula for the derivative at any x that I would want. So in this section, that was different than 3.1, was our definition turns to this. F prime of x equals the limit as h approaches 0. And the only thing that's going to change, instead of putting our a's in, we're going to have x. So we have the y ahead, right? F of x plus h minus the y behind, f of x, divided by, and then if I were to do x plus h minus x, what I would get left with would be h. X's would go away. So there's my definition. So I like to scaffold this, meaning I like to find each part individually so I don't get overwhelmed. So I'm going to find f of x plus h first. So, and these are s's, I guess. So these would all be, I guess we can stick to that. Actually, I lied. Leave them, because my s's are going to look like 5s. So I'm going to do this instead. All right, now I'm going to do that. Doesn't really matter, but you know. All right, plugging this in. 3 times x plus h. Okay, that cubic, I'll show you how I would do it really quick. If that'll make a box, I'll just leave it, it's not too bad. I'm going to do x plus h times x plus h first. That's going to give me x squared, xh, and h squared here. So that answer would be x squared plus 2xh plus h squared. Now I have to multiply that, x squared plus 2xh plus h squared. I need to multiply that by another x plus h because it's a cube, right? So I would do a 3 by 2 box. Right, see if I correct it. Oh, it did. Okay. So 3 by 2. Okay, so I'd have x squared, 2xh, and h squared. Then I'd put x plus h over here. So I get x cubed, 2x squared h, x h squared, x squared h, 2x h squared, and then h cubed. Why I like this is if you look, all these, most of the time this happens where our like terms are in the diagonals there. Okay, so my answer then, okay, this is going to be 4 times, and I take the stuff out of the box, I get x cubed plus 3x squared h plus 3x h squared, and then plus h cubed. I'm going to have to make that smaller. I just like crammed all the room out of the way. Right, there we go. And then we have plus 3x plus 3h. And then that 4 will distribute. 4x cubed plus 12x squared h plus 12x h squared plus 4h cubed plus 3x plus 3h. I think that's correct. Let me double check since you guys can't correct me here. Oops. Yep, I think it's all good. So, and I actually, do I even have any common terms? I don't think I do. So the next thing we're going to have to do is take that and minus f x plus h minus f of x. Okay, so let's kind of do this all at once looking at that. I'm going to minus from this that I have here, right here, right? I'm going to minus from that this, or let's write it out because it's kind of sloppy there. I'm going to minus this away from that. Right? So I'm just going to take, if you look at what I have circled here, I have 4x cubed in both and 3x in both. So I'm just going to take that out. So I get 12x squared h plus 12x h squared plus 4h cubed plus 3h. Okay? Then we're going to take f of x plus h minus f of x, and we're going to divide it by h. Well, if I look, I think everything has an h in it, so I'm just going to reduce everything down by an h. So I get 12x squared plus 12xh plus 4h squared plus 3. So now I can do the limit. Okay, the limit was the limit as h approaches 0, and now I'm going to put in what we just came up with. It's 12x squared plus 12xh. I wrote a 2 though. 12xh plus 4h cubed plus 3. There we go. And h is going to 0, so I just lose those terms, and it leaves me with 12x squared plus 3. All right, that is the derivative function, right? Creates a function. Now, if I want the derivative, remember, which is the slope of the tangent line at any point, I could just put that point into this function. So that's A. And then they just wanted us, and this is what makes it nicer, is I have this function now. So they want us to find it for A equals -3 and -1. So I'm just going to do f prime of -3 is equal to 12 times -3 squared plus 3. Okay, well that's equal to, that's going to be 9 times 12, which is 90 plus 18, which is 108, which is 111. All right, so we have the slope of the tangent line at -3, x equals -3. I also can pick up really quick any other number I want. It wants me to do -1. So -1 squared times 12 plus 3. That's going to end up as 15. So remember in class, or like from the other video from 3.1, the practice problems, if you take a look, we would have to do it twice through that definition to get this. But since we let our definition above here, and it does make it harder to evaluate over here, I believe, because we have like x's and h's. But doing that work will produce some kind of function. All right, take a look at practice 2. We're going to do the same exact thing here. So we want to write the definition, f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Remember, that's a slope. We're just taking the limit and letting h get really small. It makes my interval really small. Right, so I'm going to use the right side of this to figure this out because these are polynomials, so they take a moment. So f of x plus h is equal to 3 of x plus h squared plus 2 of x plus h minus 10. All right. I'm going to do the square force just to save some time in the video. Since I did the cubic earlier, just use the box. So it's x squared plus 2xh plus h squared plus 2x. I'm going to have to move this over. 2x plus 2h minus 10. I multiply that through. Now 3x squared plus 6xh plus 3h squared plus 2x plus 2h minus 10. I don't think I have any like terms there. No. So now I have to do f of x plus h. I'm going to do a line here if you'd like to make it separate so you can see the steps. Okay, we have that. It's going to be what we just came up with, what I just underlined there, minus this function here. So you can see that I have things that are going to go away, right? 3x squared is going to go away with 3x squared. 2x is going to go away with 2x. Minus 10 is going to go away with minus 10. And I'm going to be left with 6xh plus 3h squared plus 2h. So the multiplying is kind of annoying, but the more you do it, right, it's going to become faster, and you'll see that you'll get through these problems really quick if you just put some reps underneath you. Right, the next one I got to do f of x plus h minus f of x, that's what I just had, right? And I'm going to divide by h. Each term has an h in it, so I get 6x plus 3h plus 2. And I'm simplified down now, so I'm going to use that in my limit. The limit as h approaches 0, and then we do the function that we just came up with, 3h plus 2 And you can see I'm going to let h be 0 now, and I'm going to get left with 6x plus 2. All right, so we just found a function, f prime of x is equal to 6x plus 2. This was A. B wants us to evaluate for the values of A. They only gave us 1 this time. So it's A is 1. So f prime of 1 is equal to 6 times 1 plus 2. So that's equal to 8. Okay, but the directions didn't say just to find that. It says find the equation of the line tangent to the graph. I'm wondering if now the example above, the practice there, said that. Let's look. Nope, it just said to evaluate. Cool. So we have that, and then to get a point, it's a equals 1. I just have to plug a into that formula there. Right, so let's do that. F of 1, so that's 3 times 3 of 1 squared plus, I'm using that formula up there, plus 2 times 1 minus 10. Okay, so that's equal to, it's going to be 3 plus 2 is 5 minus 10 is negative 5. So the point that I have is 1 comma negative 5. Sorry, I keep lifting my iPad up if you guys are hearing a slamming noise. I'm trying not to do it. M is equal to 8. And then I use those two things in my line formula, right? Using point slope, because it's faster than mx plus b. I got 1 plus 5 equals 8 times x minus 1. And we're done. So these are, I feel like, but I've been teaching this topic for a while, but I feel like this is definitely one of those problems that if you were to do 5 of them or even more or whatever, maybe even 3 could be enough for you, but put enough underneath, I keep saying underneath your feet, but like get reps there, right? I know that when I do it more often, I'm like, oh, this process actually isn't too bad, especially when I do it like this, where I'm working off to the side over here to get through my scratch work. It feels just much less overwhelming because I didn't have to write limit a million times, and then I also only had to accomplish 3 things one at a time. Just made it feel better.